This talk is about retinal oxygenation with a damaged choriocapillaris. Generally, damage to the microcirculation prevents nutrition of some of the adjacent tissue. The choriocapillaris is the microcirculation of the choroid, and there are situations in which the choriocapillaris is damaged. If it's damaged, what does this mean for retinal nutrition, specifically for the supply of oxygen to the retina? The choroid in an intact, dark-adapted retina supplies at least 80% of the oxygen requirement of the photoreceptors. We've measured PO2 across the retina with oxygen-sensitive microelectrodes in anesthetized animals under many conditions. Measurements in cat and monkey are similar, and we think that this means that the measurements would be similar in humans as well. Here's an oxygen profile across the retina, again just for background. The way we make these measurements is we put a microelectrode all the way into the retina, past the retinal pigment epithelium, and then gradually withdraw it, which generates this map of oxygen shown at the top, roughly correlated with this picture of the retina at the bottom. The choroid is at 100% depth in these maps, and the vitreous is at 0% depth. They're characterized by gradients from the choroid down to the inner segments of the photoreceptors and from the retinal circulation down to those inner segments. And there's a very low minimum PO2 there because of the high oxygen consumption by photoreceptor mitochondria. These peaks in the inner retina just show that we are close to the retinal circulation. Now we're focusing here on the choriocapillaris PC, or PC as we call it, and that's the PO2 at the very back of the retina. We did some experiments to try to investigate the mechanism of panretinal photocoagulation, or PRP. We made lesions with an argon laser in the cat retina, and that caused the destruction of photoreceptors, which also left the inner retina intact. As you can see here in this picture, taken about a month after photocoagulation, there's normal retina on the right, showing all of the normal layers, but on the left is damaged retina, which is completely missing the outer nuclear layer, and the photoreceptor inner and outer segments are simply disorganized. But the internuclear, interplexiform, and ganglion cell layers are present. Now these lesions were larger than in human PRP, so that we could measure PO2 in the lesioned areas. Remember, our electrode goes in on an angle. And we didn't want to move into a lesioned area or out of a lesioned area. We wanted to stay in a lesioned area or stay in a control area. But the layers we damaged were the same as in human PRP. Before I show you what happened with oxygen, I want to show you that these lesions destroyed the choriocapillaris as well. On the left is a fundus photograph, and it looks pretty bad because the tapetum is also destroyed in these pictures, so that the reflective surface of the retina is damaged as well. On the right is a microsphere measurement where we've injected microspheres into the heart. They've impacted in the choroidal circulation. This is a flat mount of the choroid. And you can see that in normal parts of the retina, you have lots of microspheres of two different colors, but in the lesioned area, there are no microspheres at all, meaning that there is no blood flow, no capillary blood flow in this region. And you can also see this if you do indocyanine green pictures. So here's a lesion in this picture on the right, and there's another lesion up here. The splotchy appearance is the choriocapillaris. It's missing in these lesioned areas, but you can see the larger vessels of the choroid behind it. So what happens to oxygen? Well, the key finding is that the retinal PO2 at the choroidal boundary changes very little after photocoagulation. At the top is a profile from a control area in one of these animals. At the bottom is a profile from a lesioned area. And the profile changes dramatically because the photoreceptors are gone, so the trough caused by photoreceptor oxygen utilization is also gone. But the PO2 at the choroid is actually not changed very much at all. even though the choriocapillaris is missing. You can see that in all of these different animals where the black bars are control areas and the white bars are lesioned areas. And if we look across all of these animals, the PO2 at the choroid is about 85% of the control value in the lesioned areas on the average. Now we also made small lesions. They have no choriocapillaris either. We were not able to make oxygen measurements in these animals, but we could make lesions which looked very much like PRP lesions, and we could also make microsphere measurements. And it may be a little harder to see in this picture, but there are no microspheres in the lesioned areas in the retina. Now we are not the first to see this. In the 80s, Perry and Risco did some measurements and made vascular casts of the choroid after doing photocoagulation lesions. And you can see these holes in the choriocapillaris on the left. What they found was that those could heal somewhat over time, and you had a restoration of some of the choriocapillaris. But we did not really find that. Our choriocapillaris seemed to be damaged for at least a month. So the PO2 at the outer border of the retina is affected rather little when the choriocapillaris is gone. And what does this imply? Well, we think that the reason for the relatively normal choroidal PO2 is that the choroidal tissue itself does not use much oxygen, and less oxygen is removed from the choriocapillaris after the lesion because the photoreceptors are gone. So the PO2 stays higher in the choroid. And we know that arterioles in general leak oxygen, even in tight endothelia, as in the retinal circulation. So we think it's very probable that the arterioles in the choroidal circulation are supplying the oxygen now to the retina. So these three elements really allow the PO2 in the distal retina to remain nearly normal. So when the choriocapillaris is missing, the diffusion from the choroidal arterioles is adequate to provide oxygen to the retina. The choriocapillaris is probably damaged in human PRP, just as it is in cats, but we have no OCTA measurements that would help to verify that. But what we found in cat is very likely to occur in humans. Now, what about situations other than PRP? OCTA shows that there is complete or partial loss of the choriocapillaris in some other situations. There are now known to be flow voids in the choriocapillaris. Geographic atrophy damages the choroid, and so does diabetes. And just to look at a couple of these pictures, here's the choriocapillaris showing flow voids, these black spaces in the choriocapillaris. If you calculate how much of the choriocapillaris actually is blank or does not show perfusion, it's about 17% of the choriocapillaris surface in this one study. Now, these voids actually get larger with aging, and the implications of that, the consequence of that, is not really known yet. A more prominent example of loss of the choriocapillaris is in geographic atrophy, where you can see on this OCTA picture that there is really no choriocapillaris, but significantly the larger vessels of the choroid are evident here. So maybe the choriocapillaris is not really necessary. Maybe we shouldn't worry about the loss of the choriocapillaris too much if the rest of the choroidal circulation is okay. And maybe the loss of the choriocapillaris is not the most important aspect of diseases like geographic atrophy. But it's difficult to believe that the choriocapillaris is unimportant. The choriocapillaris does allow PO2 at the RPE to be at least somewhat higher, which may be important. And it's possible also that while oxygen diffusion is not seriously impaired, the diffusion of other substances with slower rates of diffusion might be impaired. Either diffusion of nutrients into the retina could be slowed down, or waste products out of the retina could be impaired. Nevertheless, we think it's interesting that without the choriocapillaris, the PO2 at the back of the retina is remarkably little affected. So thanks for your attention.